In this video, I will show you how to use scatter plots as one way to visualize where to make the breaks in your data when you're creating subpopulations. What you see in this video, you see the completed exercise that I went through in class. And we're estimating height of people based on their age and their weight. And if you look at the summary information here, we have age in years, we have gender, and then we have height and weight. And we're trying to estimate height. So how did I do this? I did it with visualizations. And one very useful way to do this is through scatter plots. We're trying to predict height, and age in years is one useful indication of how tall someone is. A couple of things show here. One is that it's a curvilinear line. You can see how it has a very steep incline, and then it sort of like flows over, and then you can see it sort of stop going up so much over here. This is how people grow. You can also superimpose on this or make it visible in terms of gender. And one of the things that is very visible is what happens in the sense that for a while boys and girls are pretty much the same height, and then girls start having a bit of a height advantage in those early teen years, and eventually the boys' height gets greater and overtakes the females. You can see that the females' heights sort of level out. They stop growing in those teen years after maybe 14 or 15, and they're leveled out here. And you can see the boys have sort of taken over. And that means some things. It means that curvilinear lines are going to be better fitting than straight lines. I pretty much can just predict this by just looking at this graph. We can see that age matters. Because if we're going to want to split this very steep portion of this first 3 years off of this curve, and then things get fairly stable for a while, and then we have this this sort of like decaying off where things are not going up as steep as the slope for the girls, and the boys overtake the girls. We also can take our not just our age in years, but we can also look at weight. Weight is related to height as well. You can see that this relationship is very curvilinear as well. And you can also see that as we get into the kind of the middle of the weights, which also we know is related to their ages, then we're here, and then you can also see that eventually the boys are taller in relation to their weights. And so this is curvilinear too. So it's another clue that polynomial curves will be better than linear curves on this. So what did I do? Based on this information, then I split this first 3 years off, and then took the 4 to 12 years and did this. And then once I got over 12, I split it into males and females. Before I started through all this process, I went to see what my one-size-fits-all model would give me. And so if we look at a linear model, it gave me an root mean squared error of about 4 and a MAPE of about 8. If we took the polynomial model on that same data, it should be better, and it was. This polynomial did a lot better. Instead of a root mean squared error of 4, it was only 1.38, and the MAPE was much lower too. So this is a much better model even on the one-size-fits-all model. So I'm just removing this linear regression because it really is not as good as this model. But when you look at the compound model is much better than that still. Our root mean squared error is 0.406, so we're typically off less than half of an inch in our estimates. Here we were off an average of about 1.4 in our estimates. And so you can see that by having the compound regression model work, by getting all of these various splits, that we really did better. So when all was said and done then, I removed this, and I had these 5 child models, and I have to take this off before I can create a compound model. But once I have all of my child models that are, the data is mutually exclusive, there's only one model per child, or I could have done ensembles if I wanted to at these child levels, because an ensemble under one data section can be thought of as by BizMiner as a single model. Once that was done, then on this data, this partition data set, I could say create compound regression, and it came up with this model.